All right, so I'm super excited about today's class because today we are going to think like engineers. You're going to see code you've never seen before. You're going to get a little bit confused, which is natural, completely natural. But what I want you to do from this session, and you'll hear me repeating this, uh, you know, uh, a few more times, don't try to cram any code. Okay, don't try to cram any code. Just understand the basic flow of information. Just know to get here we have to do this, to get here we have to do this, and then you only have to understand the little parts of code that you can understand. Don't try to cram everything. That is now where tech becomes really boring, and I don't want it to be boring. Evans Omondi, we are supposed to go 2 hours every class. Maxwell Kariuki, yeah, I see you. I hope this is not your first class, because if it's your first class, you'll be a little bit confused. I advise you to go and look for a class called First Class. I couldn't figure out a better name to give it. So just look for First Class, start there. And then from there you can go to class 0, class 1, class 2, up to now we are in class 8. This is the 9th class actually. So in computer science we start counting at 0, we don't start at 1. So this is our 9th class, but it's titled class 8, which is like index. We'll look at index in a second. Oh, Maxwell, wonderful, 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 wonderful. So somebody asked about the operating system I'm using. So the problem is when I'm doing the live stream, I'm using the MacBook because of the webcam and because it handles the heavy lifting of the screen recording software. So I use the MacBook, but we've been using Windows so far, to install stuff and whatnot. But for this session, I'm going to use Linux. Don't worry, I'm not going to install anything new. The flow will just be the same: VS Code, type code, run code. So whatever I'm doing here, you can do it on Windows. If there's anything different, I will mention it, okay? So actually Linux is my primary operating system. It's what I use as my daily driver. But don't worry about that. We'll get to Linux. We have a class on Linux coming up, I think sometime next week or the week after that. So we'll look at Linux and how to use Linux. So don't worry about that. Yeah, Evans, we intend to go for 4 months. So this is the first month, second week. So we intend to go for 4 months. And without further ado, let's just jump into why we're here today. So, like I said, the easiest way to understand the entire concept of software engineering is to start with something you can relate, or something you know, or to start with a use case, okay? So, excuse me. So we do have this website called Soma Stories. It's a website I built myself. By the way, it's one of the things I'm very proud of, because I built this website entirely alone for 4 months. And then I launched it. Now it's live. It's just marketing here and there, and they get the users you want. So what happens on Soma Stories? So on Soma Stories, you write a story and then you give it tokens. You see, like this one here, it requires 1 token to unlock. And then here it will show you a balance, and then it will show you the amount of token this story requires to unlock. So I will read the snapshot of the story, and if I find it interesting, I can see it's 332 words, and so far it has been read by 2 people. So if I find it interesting, I can just come and click this unlock thing here, and then it unlocks the story. It shows me the entire story. Now I can read the entire story. As well, if I'm running out of tokens, all I have to do is I can initiate a token top up. So I can top up my account. So to do that, and it just does a direct M-Pesa SDK for Kenyans. It does M-Pesa SDK. For people outside the country, you can use PayPal or Visa, okay? So here, let's say my tokens are low. And I want to read this story, so I can just come here and say click the wallet icon, and then I can choose the amount I want, okay? So here I can choose the amount and input my number like so, and then I will click confirm top up. So of course it has to do its calculation, and then it says there's an M-Pesa prompt. So on my phone, I'll get that message saying, do you want to pay this amount to Soma Stories? So I can just enter my M-Pesa pin and confirm pay. Yeah, I'm not going to pay myself. So now after I've confirmed, the tokens will get topped up to my account, and now I can unlock stories and continue reading stories. So we do have stories, we do have books. There's the book section. There's this book I'm writing based on this course. So far I haven't written any chapters yet, it's just the synopsis. And then there's also the podcast feature. There's the podcast feature. There's this one. In this podcast I actually talk about a part of my life when I was growing up. There's a time my cousin gave me a whooping. She beat my ass really nicely. So I talk about that in this episode. Episodes as well have the concept of unlocking and locking and so on and so forth. So here I'm a writer. I've logged in as a writer, and there are quite a few other writers on the platform. It's not just me. And here it shows the total stories, blah blah blah, all that information and whatnot. If you have noticed already, there are a few data sets we can have from this platform. Number one, we can have a list of users, of writers, okay? We can have a list of stories, we can have a list of tags, and so on and so forth. But for the purpose of this class, we are only going to focus on the list of writers. So here, I'm going to log out, and then I want to log back in, okay? And to log back in, I'm going to type an account that is not there, okay? So I'm just going to type some nonsense there. And then I will click login. And then the platform will check and say, hey, invalid credentials, okay? So this is quite a little bit misleading. Let me use another platform to demonstrate what I want to explain. Let's try Facebook, for example, and try to, I do not want to log out because I don't remember my Facebook password. So let me just go to a new tab. Where's the new tab? Here. Facebook.com. So on Facebook, I want to log in. So I'll say at gmail.com. I'll type some random password and then I'll click login. So as you can see, Facebook is telling me the email address or mobile number you entered isn't connected to an account. So Facebook does not recognize this account here. But if you come here and see how many users are on Facebook, let's say Facebook user base. So as you can see, let me just change to English here. As you can see, Facebook has 3 billion users, okay? It has 3 billion users. But for it to tell you that this account, okay, this email address does not have an account, that means somehow they have to check in the list of users they have and tell you, hey, we do not have this in our user in our data set, sorry, in our users database. Okay, so that is why it was important we learn about, let me just, what am I doing? I'm supposed to move this to there. Okay. You can't see my screen, Samuel. I don't know why you can't see my screen. Anybody else who can't see my screen? All right. So now, using the example I've just given you, assuming on Soma Stories we have a list of users. Okay, this is our list of users. It's stored as username. This one here is the username, and the password, which is right here. Okay. Okay, thanks Alfie and Anzakua for confirming. So this is our list of users in the database for Soma Stories. Now, what are some of the things we can do with this list of users? Number one, a user might log in, okay? So for example, if Faith is logging in, we want to confirm, is Faith in our database? If Faith is in our database, we go ahead and confirm the password they are giving, because for you to log in, you have to give the username and the password, okay? So a user might log in. A data scientist might want to sort the list alphabetically for doing data science stuff, you know, like data analysis and whatnot. So to analyze data effectively, they would want to sort the list in alphabetical order. So if you've noticed right now, the list is not in alphabetical order. We have M here, S, K, A, B. It's not in alphabetical order. For data analysis, in most cases, you want to order your data. A cybersecurity analyst might want to check which password is weak. So if this is a very big company and you have a and you have a cybersecurity team, they might want to frequently check your database. Of course, that is not the most viable way to do it, but they might want to check the database and find out who has a weak password. And then we send them an email saying, hey, your password is weak, you might want to change it. You see, like this one right here, Ruiru Living, I don't even know what that means. Okay. What else can be done with this data? We might want to check if a username is already taken. So when somebody is logging in, when somebody is trying to register for a new account, and they are using an email that is already on the platform, so we will check, okay, you are giving us username Chebet R. So we check in our list of already registered user, is that username Chebet R taken? Okay. Alfie, we look at how Facebook does it. It's actually a very interesting way. It's a very interesting topic. So these are some of the things we can do on this data. Okay. All these actions involve some sort of searching and sorting. So pay attention to those two words, searching and sorting. So if a user is trying to log in, we will search our database and find out if that user exists in our database. If a data scientist wants to analyze the data, they would want to sort the data alphabetically. If a cybersecurity analyst wants to check which password is weak, they will search in the data and find out which password is weak using their own rules and whatnot. So there are steps to searching and sorting, which is what we call algorithms. Okay, so if you want to search, how do you do it? Do you start from the bottom? Do you start from the top? Do you just pick a random spot in the list and start searching there? Okay, so there are common agreed steps of how we do the searching or the sorting. So Stephen Milkakon, oh, that name is difficult. So if this is your first time, if this is your first class, you'll get a little bit lost. So I do encourage you to go and start with the video titled first class. So just go and look for the video titled first class and start there. So in this class, we are going to talk about sorting and searching. Okay. But we're not only going to focus on sorting and searching, we look at other things. Okay, so before we jump into the actual algorithms, there are 5 important things we need to understand. Number 1, we need to understand if statements. We looked at if statements in a previous class. We also need to understand for loops and while. We haven't looked at while, but we'll look at it in a second. We also looked at list, and inside list we're also going to look at item index. Okay, and then we'll finish off by looking at big O notation. Okay, it's not as big as it sounds. Okay, it's just time and data. This is time and data. Okay, because if you want to search through your list, there are 2 important things you want to consider. Number 1, how big is the data you're trying to search? And number 2, how long will it take to search? Okay, that is what this big scary word means. Now this is where you'll cry. I'm just kidding, you'll not cry. All right, so let's look at all these things, and we will start with if statements and look at, we've looked at if statements before, but you want to look at more advanced use cases of if statements. So yeah, straight to the code. So I have this project. I was trying to fix something here, but my goodness. Let's see. So let me just try to zoom in a little bit. That is fine. That is fine. So here I'm going to create a file called main.py, and then inside main.py we are going to start very simple. Actually I did not prepare for whatever code I'm going to type here. It's all just coming. Please use a black background. Okay. So for the tool I'm using here, okay, I'll try to see if black background will work well. But now on VS Code, we are going to look at if statements, and you look at what we call nested if statements. Okay, nested if statements. So here, if statements, and nested if statements. Okay. So down here, let's create a list. Okay, let's create a list of foods, and we'll say inside foods, we have Nangaria. That is Nangaria. Okay. So if you don't know what Nangaria is, it's this interesting ugali like. It's maize flour, and then I don't know if they add blue band. And then they add, I don't know, I have forgotten. It was a long time ago since I last tasted Nangaria. But it's a dish very common in Turkana or Lodwar. So we have Nangaria, we have ugali, we have cabbage, we have, what else do we have? We have pizza, we have, what else? Chicken. Oh, chicken. I've just said chicken and remembered I haven't had my supper. That is the Luya in me talking. And then we have tea. All right. So this is our list. You would imagine, for example, this is a hotel and they have these foods available. Now, it's also interesting to note that you don't have to type your list like this, okay? You can type your list going down. So here we can just say that goes there, and then that goes there, and then that goes there. It seems like a lot of work for me. That goes there, that goes there, and then we have these closing square brackets. Okay, so your list can be in this format, or it can be aligned you know, in one line. Now, what are some of the things we can do to this list? In regards to if statements, we can try to check if cabbage is in the list. Okay, so here we can say if cabbage in list in foods, our list is foods, we want to print yay, we have cabbage. Nobody likes cabbage that much. So let's run our code and see what happens. So in your VS Code, you might run Python, just Python, and then you say main.py. But since I'm using Linux and there's a way I've configured Python, I have to use Python 3. I have to use Python 3 main.py. And then I'll hit, and then I see, yay, we have cabbage. Okay, so if you remember with if statements, if this returns false, we don't execute the code inside it. If this returns true, we execute the code inside it. What if we use a different item here? And remember, I'm using a small c. I'm doing that on purpose. Okay, I hit enter, nothing happens, but we have cabbage. But if you check closely, this cabbage here has a small c, but the one in our list has a capital C. So that is why it's not found. Okay, so this is an if statement. But what of, let's add an else here so that our code doesn't just, you know, go silent. Else we want to print, sorry, we don't have that. Okay, so let's look at if statements. What is if statement? So inside an if statement, we can add another if statement. We can say if pizza in foods, we want to say print pizza in food. Why is your hand on my face? Get it away. Okay, so we want to say this is my head of media. Come and say hi. This is my head of media. She's doing her thing. So we want to say pizza in food. That is a nested if statement, and then we want to run our code and see what happens. So we are getting sorry, we don't have that. But we have a nested if statement here. So what happened to our nested if statement? So let's have a look at that. So the first if statement will return false. And if it returns false, everything inside it will be ignored. So Python will not, try to zoom in a bit. Hash, what are you using your phone? Okay, let me just try to zoom in. Okay, so the first if statement returned false. So nothing else inside it will be executed. And remember, when I said inside it, I mean anything indented inside it, like so. So this all will be ignored. But let's try and see what if this returns true. So we'll use something that we have in our list of food, and then we run our code again. And then as you can see, pizza is in food. Yay, we have cabbage. So since this returned true, these two pieces of code here were executed. And this is basically a nested if statement. You can nest as many if statements as you want. We can nest another if statement here. If for example name, and here we can just create an empty variable called name, and we give it true, so that our if statement returns true. And then here we can say if name print name, we want to say name is true, and then we run our code again, and then as you can see name is true, blah blah blah. But what if the first if statement here returns false? What if we use something we do not have? So let's say carrots. Okay, so carrots is not in our list, so this is going to return false. So what happens to all this code right here? So let's run our code again. Okay, yeah, so all this code was ignored. Okay, in the engineering sense, we don't say ignored, but all this code was ignored because this one returned false, and then we skipped right to this part right here. So that is if statements and nested if statements. And in the previous class, when we were looking at functions, we also learned that we can even nest if statements inside a function. Okay, what else was there we were supposed to learn? For loops. Okay, so let's look at for loops. So we'll use the same list we had, okay? And then here we're going to just say something like for item in foods, we want to print the item. We want to print item. And remember I said this item can be anything, okay? It can be it can be dog, it can be whatever. So in this case, this is a placeholder. Okay, because we want to go through the entire list, and that is what for means. So for means go through the entire list and use this as a pointer of where you are. So for example, we are going through the entire list. For item, we look at the first one, in foods, and then we print that item. So we print Nangaria. But that is not the end, because for keeps running. Okay, so we again say for item in foods, we go to the second item, which is this ugali, we print the item. So if we run our code right now, we can see all the items are being printed. But imagine you want to go through the entire list, checking what is there, but you don't want to print everything. We only want to print if a condition is met. So inside the for loop, we can nest an if statement. So we can say if the item we are looking for is ugali, we want to print a item is ugali. Why did I use 2 quotation marks? Supposed to be 1, like so. So remember here all the items were printed, but let's see what happens when you run the code now. So when you run the code, what am I doing? Oh, an if statement is supposed to end with a colon. My goodness. Let's clear and run our code again. Okay, I'm supposed to indent this guy here. Let's indent that guy. Clear again. Let's run our code, and then as you can see, item is ugalu. What did I type? Item is ugali. It's supposed to be ugali. Okay, so this is how you can combine an if statement and a for loop to get whatever result you want to get. And like I said, don't try to cram the code, understand the logic. So the logic here is you have a list of items, okay, and you want to go through the list and print everything that is in the list. However, there's only one condition for the print to work. The item has to be ugali, okay? If there's anything else, we don't bother, okay? So you would imagine this is somebody who has come to the hotel and asked you, do you guys cook ugali? So you want to go through the entire list of things you cook, and if you find ugali, you tell them, yes, we cook ugali, okay? Githeri also, Desmond, I see you. Okay, so this is how we nest for and if statements, okay? Now let's go to, we've looked at list, of course. Now let's go to index, okay? And index, essentially index means the position of that item in the list, okay? So let's try and find the position of Nangaria in our list. So we'll say for item in foods, if item is Nangaria, this is actually a very dirty code, and you look at why and why I'm saying that in a second. So we want to get the index of Nangaria. How do we get the index of Nangaria? But before we get into all this mess, let me just start with a clean piece of code. So we have a list, okay, and we want to find out in this list who is at position 3, okay? So how do we do it? We can say print foods, and then you use these brackets, and then you say position 3, okay? Let's see what will be printed at position 3. So we run our code, and as you can see, position 3 is pizza. Let's confirm 0, 1, 2, 3. Do you now see where the 0 is coming in? Yeah, we count from 0. But what if we want to find out which item is at the very first index? What should we use? Should we use 1 or should we use 0? Here we use 0. So we'll say 0, and then we run our code, and then as you can see, the item at index 0, which is the first index, is Nangaria. So this is how you access an index. So in the code that you're going to look at, we'll see a lot of this, okay? And just know whenever we see this, it's the index we are trying to access. And I'll just give you an example. Let me just zoom out here. Like this code right here. So basically we are saying get the index of J and then add 1 to that index. So if J is at index 3, then add 1 to that 3, we get 4. The same thing we are doing here. So we are getting a list, user list, and then we are getting J here, which is the index of that J, and J is referred somewhere up there. But let me not confuse you guys this early. Let's just go back to where we are. So that is on index. So whenever you just see this, just remember it's an index. And there's quite a lot you can do. You can blend for loops and if statements to to see how you can work with index. So let's see how we can blend in a for loop here and an if statement. This code is dirty, but just to show you guys how things flow. So we'll say for food in foods. Remember, can you notice I'm using food now and not item? So I'll say for food in foods, if food at index 0 is Nangaria, then I keep forgetting the colon. We want to print Nangaria tops the list. And remember, I told you guys, if you want to understand code, tell a story, okay? Say it out as you're trying to type, okay? So let's see. Oh, this is a wrong spelling. Nangaria. So let's see what happens. Clear. So here we are not going to print this. In fact, let's just comment this out, and then we run our code again. And then let's see why nothing has been printed. Oh, there's an issue here. It's supposed to be Nangaria. That name keeps confusing me. So let's just get this, and then you paste it here. So what are we saying here? We have a list of foods. Index 0 is Nangaria, index 1 is Ugali, index 3 blah 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 up to index 5 is tea. Okay, and then we have a for loop here. So we are saying for food in foods, if food index 0, so if the food at index 0 is Nangaria, we want to print this. Else, don't print anything. So here we'll come and say else. We want to print index 0 is not Nangaria. So let's run our code again and see what happens. So index 0 is not Nangaria, index 0 is not Nangaria, index 0 is not Nangaria. What did I want to show you guys here? I wanted to show you that if you use a for loop, it goes through the entire list one by one. So what happens here? Index 0 is not Nangaria, index 0 is not Nangaria. So somehow this returns false. So let's see why this returned false. If food index 0 is Nangaria, can anybody see the error there? There's a bug. Why our code printed index 0 is not Nangaria, but as you can see here, index 0 is Nangaria. So why was this code executed instead of this? Because this returned true. Does anybody see why? Yeah, so it's because you see this here. This is referring to our list. But here we are saying food. Food is a pointer, it's not the list. So this is supposed to be foods, okay? And then we run our code again. And then as you can see, Nangaria tops the list, Nangaria tops the list, Nangaria tops the list. So what does that tell us about for loops? For loops is like a loop. It will go through the entire list. So it goes here, it gets Nangaria is at index 1, it executes this code. That is the first loop. It goes through again, it goes through the list again, it finds index 0, it goes through the list, it finds, okay, index 0 is Nangaria, but we are here. So we'll still run this piece of code right here. Confusing, right? Don't worry. So that is why this is printed the same number of times as the length of the list. So what if we have only 3 items on our list? What if we have 3 items? Let's see if it will print this 3 times. So I'm going to delete everything and say Python, and then as you can see, it's printing 3 times. What if our list had only 2 items? Or what if our list had 1,000 items? The loop will run 1,000 times, okay? It's because the for goes through the entire list, okay? Yeah, loops in JavaScript and in Python are a little bit different, but the concept is the same. There's just the introduction of brackets and, you know, squiggly brackets, but they are pretty much the same. Okay, so what else is remaining in this list? We have for loops. We haven't talked about while. You see this while here, and while is like a for loop, but it runs sort of like forever. Okay, so let's go to our code and try to see how we can learn while. So here we are saying for food in foods, and then we execute more code inside it if this returns true. But what of while statements? They say while statements, but let's just say while loop. So we'll say while food at index while foods at index 0 is Nangaria. So we'll say Nangaria. That's supposed to be Nangaria. We want to print, let's print something interesting. Meow, meow. Do you know, but I told you I have a lot of talents. That's another talent. Add it to the list. Meow. All right, so let's run our code and see what happens. As you can see, our code is still running. It's still running, by the way. See, it's running. Okay, and it will run forever until you cancel it. So that is the meaning of while statement, okay? So while means, if this is true, keep running whatever code I have inside here, okay? That is what it just means. At least for a for loop, it will end when the list ends. So if your list is 100 items, when it gets to 100 items, it stops. But for a while loop, it continues running forever, okay, until you end it. So a more relatable example, let's say we want to print, what do we want to print? Let's say we want to print 1 to 10, okay? So let's just delete everything and say, we want to have a stop, and then we say, no, we want to have a start or a number, just any number. We want to have a number, and then this number will be 1, okay? And then inside you want to say, while our number is less than 7, then the colon. So you want to print the number, and then as we print the number, we want to go back to the top of the list and increment our number. So we'll say number equals to number plus 1, okay? Don't cram anything, just try to understand that a while loop or a while statement will run forever until a condition is met. So our condition is right here. This is our condition, okay? So let's run our code and see what happens. And then as you can see, it prints 6 times, okay? So here it's because we've said we are giving a number 1. What if we give this number 9, okay? And then let's run our code. Nothing gets printed because this condition evaluates to false. The number is not less than 7. The number is higher than 7, which is 9 here. So that is for loops. Are you together? Who is lost? All right, let me give you guys a second to, take a sip of water or internalize. Is it internalize? Whatever. Before we talk about big O notation, this thing right here. Babe Jamani, you ask so many questions. I'm trying to in an hour. All right, let's go to big O notation and see what this big O means. And like I told you, big O basically is a concept we use to measure where together. I don't know what that means, Kimathi. Which language is that? So big O notation is a concept in computer science where we try to calculate the time and the data that you feed into the system. Okay, the data that you feed into the system and the time the system will take to calculate or to execute your instructions. This is important because if you are in our earlier classes, we said the whole business of computer science is data and manipulating data and presenting data, okay? So when you give, it means we are together. Okay. Together, my goodness. Okay, I'm sorry, we are together. So big O notation essentially means the amount of data we feed into the system and the time it takes. And even before we go through all this, let's just look at what that means right here. So assuming you have 1 billion users in your database, okay, and you want to go through the entire 1 billion users, how much time will it take depending on the format or the algorithm you choose to go through your entire list, okay? So if you have a list here and you give this list to 2 people or 3 people, okay, the first person says, I have to go through the entire list, but what I will do, I will start here and I will go through the names one by one up to the last one, okay? How much time will it take? Let's say it takes 5 minutes, okay? And another person says, I'm not going to do that. What I will do is, I will go and start at the middle, okay? I'm looking for one person in a list of 1 billion users. So I will start in the middle at, what is half of 1 billion? 500 million? Yes, 500,000 million, 500 million, 5, my goodness. Anyway, so one other person, so let's call this person A, will start at the top going down. Person B says, nope, I'm not going to do that. What I will do, I will start in the middle. You're looking for one person. So I will split the data into two. So instead of going through the entire 1 billion list, I'm going to split it in the middle and pick this first half here. And then I will go through these people, okay? And then I will compare. Is this person's first name alphabetically, does it fall under this list? If it falls under this list, then I focus on that list. If it doesn't fall under this list, then I will focus on the second half. So these two people have used different algorithms. The first person has used what we call a linear search, whereby you start on one spot and then move linearly as you try to search. But this person has a different approach. We'll look at that approach in a second, okay? So they will each have, the data is the same, 1 billion users. But this person might take longer because he's going through the entire 1 billion records. But this person might take way less time because they've split the data into two. And then instead of going through 1 billion records, they'll go through 500 million records. Is it 500 million? My goodness. Can somebody educate me in the chats? No, we are not in VS Code at the moment. Hubbard. So these two people have used two separate algorithms to get the end results, okay? So that is just basically what big O notation means. It looks scary, but it's not as scary, okay? So now let's dive deeper into big O notation. So big O notation can be classified into several sort of like types. So we have O of 1. O of 1 means the time is constant. And what does that mean? This means if your algorithm, the algorithm you choose to count the list of people, and I've explained it here. Imagine you're standing at the entrance of a matatu stage or a bus station, and you have one simple question. Is there at least one matatu here? Okay, so that you just don't stand there and there's no matatu. So you want to figure out if there are matatus. What do you do? Scenario 1, there's one matatu. So you look at the first slot where that one matatu is, and you find that one matatu. That's it. That's all you're bothered with. Okay. Scenario B, there are 1,000 matatus in that stage. Okay, 1,000 matatus. If you want to, if your question is there any matatu in this stage, you will only look at the first matatu there and say, yes, there is a matatu. So you don't care about the 1,000 matatus. So the time it takes you to look at one matatu and say, yes, there is a matatu is 1 second, whether you have 10 matatus or 1,000 matatus, okay? And you can look at it this way. You have 10 matatus, you look at the first matatu and say, yes, there's a matatu. I don't care about the others. It takes you 1 second, okay? But the stage has 100 matatus. What is the time it will take you to answer the question, is there at least one matatu here? It will take you again 1 second, because you only care about that one matatu in the front of the line. You don't care about the other matatus. So what if we have 1,000 matatus? It will still take you 1 second. What if we have 1 million matatus? Okay, 1 million. Why is my pen so thick? If there's 1 million matatus, it will still take you 1 second. So the O here indicates the data that you're feeding into the system. And whatever is inside the brackets here indicates the time. So here we are using 1 because 1 means time does not change. Give the system 1 million records, it still takes 1 second. Okay? Time does not change. That is why we use 1. So that is what we call the constant time in big O notation. Okay? Now let's look at another big O notation algorithm here. And this is what you call the linear time. Okay? So you have to walk down the line and check every single matatu one by one until you find your friend. If there are 10 matatus, it takes you 10 checks. If there are 100 matatus, it takes you 100 checks. Okay, so you are at the bus station and there are 1, 2, 3, 4, and you have to go through these 4 matatus looking if one has your friend. Okay, so if your friend is on the last matatu here and then you go through the entire list, let's say it takes you 4 seconds. If the matatus are more, let me see, 2, 3, 4, 5, 6, 7, and then your friend is on the last matatu here, and then you have to go through the entire list looking for your friend, it will not take you 4 seconds anymore because you are looking at a higher number of matatus. It will probably take you 8 seconds, not 4 seconds. So as you can see here, if you increase the data, the time it takes increases. Okay, and that is what we call this right here, linear time. So linear time increases the more data you put into the system. And then there's this other guy here called quadratic time, and you look at a scenario here. Okay, so let's say for every passenger in the first list, you have to compare them against every passenger in the second list. Let's look at what that means in a real world use case. So let's just delete everything here. So like I've said here, accept visitors, but first check if there are any blocked visitors. If don't, allow them. So let's use, I'm trying to, where is that thing? This one. So you have a list. Okay, you've gone to a nightclub or a night party, a birthday party at somebody's home. Okay, and since you do not contribute enough money to eat, they give you some work so that you can eat. So they give you 2 lists. They give you list A and they give you list B. Okay, and then they tell you this list A contains all the visitors who were invited, or all the people who applied to come to this party. So these people will come, but you check, you say, you applied to come to this party, but are you allowed in? So there is another list B, which now has a list of only allowed people to come in to go in and eat. Okay, so as the person standing at the entrance of that house, okay, where the party is happening, okay, you have 2 lists and you have 1 job. If this person applied to come and he is in the allowed list, you allow this person to enter, to enter into the house, okay, into the party. That doesn't sound right. Anyway, so if, for example, you have 10 people here and you have 10 people here, you will have to look at 100 records, because you look at this list trying to look for that one person. Is he in this list? You go through the entire list. Okay, fine, you find them in the first list. Are they on the second list? You again go through the entire list. So here it will take you 10 times 10. You'll have to go through 100 records. Okay, now assuming this list is 1,000 people, okay, and then this one here is also 1,000 people, that means you'll have to go through 1,000 times 1,000, that's 100 million, 100 million, 10 million. Okay, let me just draw the zeros. 1, 2, 3, and then we have 1, 2, 3. Oh, that is 1 million. Okay, so that means you'll go through a list of 1 million. So if you've noticed here, the time and the data does not go, linearly in sort of like a fixed, predictable way. The time doubles the moment the data you put into the system doubles. So if you give this person a longer list, the time will even quadruple. Okay, because it will take them way longer to go through the entire 2 lists. Okay, and that is why we call this quadratic time. So another example is, for every passenger in the first list, you have to compare them against the passenger in the second list. Okay, if you have 10 people, you do 100 checks. That is 10 times 10, and the number continues to increase. Okay, so and I've shown you an example here. So you have a list of visitors. We have Kamau, Atieno, Mudhoni, Wekesa, Mohammed. okay? And then you have another list of blocked or blacklisted visitors. You have a known user, bad actor, Wekesa, blocked, spammer. Okay, so as you can see, these people are not in this list. So you might want to go through this list, you don't find them. You go through this list again, you don't find them. So that is like 10 times 10. If this list has 10 users and this list has 100 users, that is 10 times 100. Okay, so that is why we call it quadratic time. Now there's another one called logarithmic time complexity. Between you guys and I have no idea how to explain this thing. I don't even know I understand. I don't even think I understand it very well. Okay, but what basically this means is reduces the size of the input data in each step, usually by half. And if you remember very well, I already gave you this example. I've said if you have a list of users, okay, so you have person A who will search through the entire list from the top to the bottom, the entire list. And you have person B who will split the list into two, okay, the first half and the second half. And then they ask themselves, this person we are trying to look for, are they alphabetically, are they on the first part of the list or on the second part of the list? And then they focus on the part where that person is. And then they keep breaking the list into two halves. We'll look at that in a second, until they find the person they are looking for. So let's just delete this. So now going back to our list of users, okay? We have our list of users here, and the scenario is for a login to work, the system needs to find a specific user, so they have to search. And then after they've done with the search, they may want to sort the list so that it becomes easier to search in the future. Okay, so assuming one person is logging in, when a writer tries to log in, the system needs to find the specific account. Does this writer exist in our database? Yes. If this writer exists, let's proceed and check the password. Okay, so we start at the top of the list and then we keep checking up to the bottom of the list. So we start here and then we keep searching until we get the person we are trying to search for. So here is a scenario. Someone enters the name Kamau J as the username. Kamau J is trying to log in. So let's look for Kamau J. So we start at we start with item at index 1. Is this Kamau J? No. Go to the second one. Is this Kamau J? No. Go to the second one. Is this Kamau J? Yes. So once we found Kamau J, we say we found Kamau J. Now we compare the password of Kamau. And I have a Python function here that tries to explain how that looks like. So user logging in is Kamau J username, and they've given the password. So we get the target. Oh my goodness, this is supposed to be target user, not logged in user. Anyway, so we get the target user, and then you say for user in our database, if the user is the target user that we have at that particular position where we are, we return target user found checking password. Do you now see how it blends into an actual piece of code? We'll look at that deeper in a second. Have I lost anybody? Any questions? Savage Dragon. I'm sorry to hear that. Marvin, if the user is in the first list, then we have nothing else to do. We just find the user and that's it. But then again, you are not assured that anybody trying to log in will always be at the first index, okay? Or at, in the first matatu. It can be random. They can be in the last matatu, in the matatu in the matatu in the middle, and so on and so forth. Albert, don't worry. Repetition, repetition, repetition. Identify patterns. So just hang in there. Evan Somondi, I'll share the notes. All right, so we have our list of users, but you said data is always sorted. Anywhere, data is always sorted. Even your names on the government portal, they are sorted either alphabetically or by ID, so that it becomes easier to find where you are. You would imagine, for example, if you want to change your car number plate, and then NTSA processes, I think, around 40,000. They have a backlog of 40,000 number plates, okay? Or if you're in Uganda or whatever, the company in charge of giving out number plates, or let's say, for example, passports, the company in charge of giving out passports, they have, let's say, 40,000 passports in a day to give out, okay? So those passports need to be arranged in a way that it's easier to look for that specific person. So the easiest way is to arrange them in alphabetical order. So you go, your name is Desmond, you say, hey, I'm Desmond, I'm here for my passport. So all the agent will have to do, they will look for D, say, oh, these are here, okay? And then they continue they continue filtering down until they get to DE, and then they get Desmond. So that way it becomes easier than if, you know, they were just jumbled up and then they have to look at each passport trying to find yours. It will take ages for you to get your passport. So that leads us to the next topic, which is bubble sort. So what exactly is bubble sort? Bubble sort is just an algorithm we use to sort a list. As you can see, this list right here, the one I was using, was not sorted alphabetically, okay? It is M, S, K, A, B, blah, 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 like so. But the one we have here is sorted in alphabetical order. You know, if you try to search through this list, even without the help of, you know, like computers and whatnot, it's very easy, because if I say look for M or Chien, I can just come to where M is right here and isolate this. So I start looking at these three, okay? So now instead of looking at 20 records, I only have 3 records to look at. If somebody says, I want you to find Sarah or Sarah J, I cannot just come and start from the top. I just try to see where S is. S is right here, and then I focus on S. So that is why bubble sort is very important. But how do we sort? Okay, how exactly do we sort? So organizing the user list, while you wouldn't usually sort a list during login, you don't sort during login, you sort it way before, and then now the data in your database is sorted before the people try to log in, okay? Before people try to log in, sorry. So we have a scenario here. You have a list of new signups on Soma Stories. People are signing up, okay? And it's random, okay? So you might have Zebra Writer, you might have Desmond, Moses Mbadi, and Alice, okay? So these people have signed up in the last 2 seconds, okay? But the data in our database needs to exist in an alphabetical order. So how do we do it? So we compare the names, okay? So for example, this person signs up right now, Zebra Writer. So we compare Zebra Writer with Desmond, okay? And then we see, is D before Z or after Z? It's before Z. So we swap this, bring it here, and then we swap this, bring it here. And that is what you call bubbling. So you just bubble until the list is ordered. So assuming we have this list right here, let's just try to write them down. No, I need to get the entire list. My goodness, I need to get the entire list. George, don't worry, you'll read the notes and get to understand. So let's say we want to sort this list. So we have our list here and we want to sort it. We want to sort it. So there are 2 scenarios. The list is not sorted yet, okay? We do not have any form of sorting. So we have to sort the entire list. So how do we do that? Let's just go start from the first one. So we look at Z, we compare it to D. Which one comes first? Desmond comes first. So we move Desmond to the top and bring Zebra down. So here, our new list now will be this. Our new list will be that, okay? So let's just end our list, okay? So we've swapped Desmond and Zebra, okay? Now, Desmond, wait, what am I doing? This is supposed to come below Desmond, like that. Yes. Okay, so now zebra is below, but now zebra is above M. So again we check, is M and zebra alphabetically aligned? No, they are not. So which one comes first? M comes first. So we capture that M and then we put it on top of Z. I keep interchanging between Z and Z. And then we proceed. Z now is at index 0, 1, 2, at index 2. We compare it with whatever is below it, and whatever is below it is Alice. Which one comes first? Alice comes first. So we get Alice, we put her at the top of zebra. Okay? And then that logic continues until the list is now ordered. As you can see here, it's not ordered yet because Alice is here, and Alice and A comes before M. So we will take Alice. We will take Alice and move her to the top of Moses Mbadi. And then again we compare D and A. A comes first. So we take that A and move it to the top. Okay, like that. So at the end we have a fully ordered list, ordered alphabetically. So we have A, D, M, Z. Now why is this important? This is important because, like, as you remember from my example I gave earlier, I've said there are two ways you can search a list. Okay, so one person will start at the middle and then pick the two halves. Okay, and then go alphabetically looking for whatever you want them to look at. Okay, and you look at that in a second again. So how you represent that in code, it looks like something like this. Okay, let me just delete this. It looks like this. Okay, it's a lot of code, by the way, and this you can just ask ChatGPT to write this for you, as long as you understand exactly what you want to do. So if I want to practice bubble sort on this list, I can just copy this list right here, and then I can go to ChatGPT, ChatGPT, and then I will say sort this list using bubble sort. I'll paste it. MMOPQR. Wait, this is already ordered. We need to get the list that is not ordered. So let me get the one that is not ordered. So I will copy this, and then I will go to ChatGPT. I'll say sort this list alphabetically. Okay, alphabetically using bubble sort, and then you hit enter. Okay, so it's sorting, but it's not showing us the code. Okay, yeah, so now this is the code it has given us. You can just try to look at the code. You can just look at the code and try to figure out what is happening. Now, the most confusing part about this code is this part right here. Okay, this is the most confusing part, and in fact it introduces another thing called range, and this range here is just an inbuilt function used to generate a range of numbers. So if you go to the browser, if you go to VS Code right now, and then we say numbers equals to range, and then we say 0, and then we say 12, and then at the bottom we come and say print numbers. Okay, so let's run this code again. That did not work as I expected. Why? Let's just get this and then put it in there. Let's delete that and then run our code again. Print range 0, 12. Okay, it's not working as I expected. I don't know why, but so essentially that is what bubble sort is. Bubble sort will go through the entire list, picking items and then swapping them. It swaps. Is the item above alphabetically higher than the item below? No, yes. and then it swaps accordingly. All right, so we were supposed to go deeper and look at binary search in this session, but I'm not going to do that in this session because I realize this session has been heavy. Has been a very complex session. So you have another example here, but I'll just give you guys a minute to ask any questions if you have any, so that you can clarify. I'm trying to format this note so that I can share. Let me see. Okay. It is saved. Is it saved? All right, it's saved. Any questions? Kuikaba, where did I lose you? Anything you want me to explain again from what you've just learned today? Oh, by the way, there is something you need to notice. Searching and sorting falls under a topic in computer science called data structures and algorithms. Data structures and algorithms takes about a whole semester to learn, and about 1 out of 5 students pass that exam. Data structures and algorithms. So if you've not understood anything in this session, that is totally okay. Okay, so what I want you to do is I want you to go and watch this video again. You probably need to watch this video 3 times for you to at least get a good grasp of what is happening. 3 times. Okay, you have to watch the video 3 times, copy the code, paste on ChatGPT, ask questions and things like that for you to understand. So it's a very complex topic, but at the same time, if you internalize it, it makes it easier for you to get into other subtopics in computer science. Kimathi, what do you mean by weight of the alphabet? We look at the okay, I'm trying to see weight. What does weight mean? Hello, DTech Solutions. So now let's look at bubble sort, but instead of alphabets, let's look at numbers, okay? And we will use something very relatable. I'll try to go as slow as possible. So let me just copy this, okay? And then you're going to paste it somewhere here. Let's paste it somewhere here. Now, going back to Soma Stories, okay? Let's go back to Soma Stories. Where is the browser? Where is the browser? Soma Stories. I need to use the one I'm already logged in. Sit here, my friend. Soma Stories. So let me just log in real quick. I'm not getting what I'm trying to look for. Why? Trending. All right, I'm not getting what I wanted to look for, but let me just explain it here. So now let's look at Soma Stories platform. Okay, we have a section that shows the trending stories. Oh no, they are not I don't think they are given weight. You just look at them alphabetically, but that's an interesting thing to look at. I'll research on that. I've actually never researched on that. Yeah, Anzaku, take another cup of coffee. So let's assume you've just entered this class and you're trying to understand what bubble sort is, okay? And you look at bubble sort and you look at a real world example of bubble sort. So we've already understood that bubble sort takes a list of, not so well organized items, and then it sorts them chronologically. It could be alphabetically or it could be by a given value. So we've said, for example, if you have a list of names, if you have a list of names here, so you have Moses, Zebediah, you have Alfie, you have what, Luna, you have Kimani. Okay, so you have this list here and you want to sort it, and you want to sort it using an algorithm known as bubble sort. How will that happen? So bubble sort will start with the first item, or it will start with the item that you give it. It does not always have to start with the first item. Okay, so bubble sort will start here, and then it compares this alphabet with this alphabet. Which one comes first in the alphabets? Okay, M comes first. If M comes first, it does nothing, okay, because that part is already sorted. It goes to the next thing. Again, it checks, does Alfie come before Z, or does it come after Z? Okay, and then here we see that A comes before Z, so it will move these above Zebediah. Okay, it will move it here, and then it moves Zebediah down. So now the first loop of our code will have something like this. Okay, so we've swapped Alfie and Zebediah. So Alfie comes on top, Zebediah goes below Alfie. Okay, so now we are here. We have to go through the entire list again, confirming that it's organized alphabetically. So what will the program do? The program again starts here. Okay, it starts here. It checks. Here we have M and we have A. Which one comes first? And then it sees A comes first. So it moves A to the top of the list, and then M, it moves it down. So now, with the second repetition of our code, we have Alfie going to the top. Okay, we now have Alfie there. Now you see, using bubble sort, we've moved Alfie from index 2 to index 1. Now that is bubble sort. Are we together now? Becky, what are you saying? Anyway, so this is bubble sort. We look at the item below the other item, and then is it higher or lower in the alphabetical order? If it's higher, we move it higher. If it's lower, we move it lower. Like so, like so, like so. So we continue doing the same using loops until now we get a perfectly ordered list. Now let's look at these using stories. So we have a list of trending stories. So story at number 1 is story A, and it has 500 likes. Stories at B is stories at second position is B, and it has 450 likes, and so on and so forth up to 300 likes. Now you see this list is already ordered. Okay, this list is already ordered, but imagine this story right here. Somebody shares this story on social media and it gets 20 likes. Okay, now this story will be 410, which is higher than the story above it. So here we employ bubble sort, because now we have to sort. Story D has to go to the top and story C has to come down. Okay, now using bubble sort, we'll go through the list. Let me just copy everything here. Let me copy this here. So using bubble sort, we want to move this to the top. So what will happen? Bubble sort will start here. Okay, it will start as story A. Does story A have more likes than story B? Yes, do nothing, leave it as it is. It goes to the next one. Does story B have more likes than story C? Yes, leave it like that, don't do anything. It goes to the next one. Does story D have more likes than story C? Yes, so it swaps. This one goes here and this one goes there. Okay, so that now our list will be something like this. So let me just delete this for our own sanity. Okay, and so now story D will move to the top, story C will move down, like so. Okay, so now our story likes are ordered chronologically. Okay, so now this one will not say it's more trending than this one will not say it's more trending than this one because of the likes that they got. Are we together so far? Have you guys understood now better? All right, I think we'll stop here for today. We'll stop here for today. Although I wanted to explain, I wanted to use another example, but it has skipped my mind. I don't know where that happens. So let me see if I can combine this into a nice note so that I can share. So this is what we've not covered in this class. Okay, this is not what we've covered in this class. Or should we just go ahead and talk about this? We have about 30 minutes left. We have 30 minutes left. Let's try to explain this bubble sort thing a little bit better. Okay, let's try to explain it a little bit better. I'm going to pick somebody in the chat so that I can use them as an example. And again, like I said, it's way easier for you to understand these things if you use a relatable example. Okay, you want to use a relatable example. Let's say Kaskwe has siblings. Okay, Kaskwe has siblings, and we want to order these siblings according to their age so that the oldest is at the top. So these siblings are seated somewhere. Okay, let me try to find something here. Okay, so let's look for an icon. I'm looking for a people icon. Where is it? Okay, so we have siblings, Kaskwe's siblings. So let's use that example, Kaskwe's siblings. Okay, and these siblings, they like to fight. So we want to find out who is older than the other. So the first one here is called what name should we give these people? Let me just look for some random name. Let's say Tate. The second sibling is Marlon. The third sibling is Japheth. And then we have Mary. And then we have Trufena. Okay, now I want us to understand linear search and bubble sort, and I want us to use these relatable examples. So we say Kaskwe has 5 siblings, and these 5 siblings have different ages. Okay, we have the oldest, we have the youngest. Now we want to give these siblings some food. But we can't just give them food randomly. We want respect. We want the pecking order to be observed. So we want to start with the oldest person or the oldest sibling. We give that. We give him or her food. We go to the one below that sibling. We give them food, like so, until we get to the youngest sibling. So the youngest sibling will be the last to get food. Are we together so far? Now grab a cup of coffee or whatever. Put your phone away. If you have earphones, plug them in so that you don't get distracted. Okay, let's start. So now Tate is, let's give these people age. Okay, Tate is, let's say, 45. Okay, now the line of food, where the food is being served is right here. Let me see if I have a sufuria icon here. Do I have a sufuria icon? Let me just use this. Okay, so this is where the food is. Okay, let's even put a line here so that people don't misbehave. Okay, now this is Kaskwe's home. Okay, Kaskwe's mother or father has 5 siblings. Okay, 6 plus Kaskwe, but let's just put Kaskwe aside. So these 5 siblings, we want to give them food, but we don't want them to come, you know, like they are. We want the first person to be the first one served, and then we keep going up to we get to the youngest. So Tet is 45 years old. Marlon is, let's say, 30. Japheth is, let's say, 60. Mary is, let's say, 100. No, I have to go lower. So let's say 23. And then this person right here is the last person. He is 5 years old. Are we together so far? I haven't lost anybody. Okay? So we want to give these people food, but we can't start with this person. He's at the front, but we can't start with her or him because he's the youngest. He's supposed to be over here. As a matter of fact, the person here is supposed to be the one here because he's supposed to be the one being given food the first. Okay? Okay, you know, in some families you might want to put the oldest last, but for the sake of this article, for the sake of this tutorial, let's use what we are going to use here. So before even the food is given, we want to start ordering these people, okay? And we want to use bubble sort. So what does bubble sort do? It starts with the first person here, okay? And then it compares with this person. Remember, we want the lowest number to be at the end and the highest number to be here. So it will start by comparing these two, okay? So now we have a new list. Let me zoom in, move this here. So we now have a new list. So bubble sort will compare the first two people. Remember here we are comparing by age, not by name. We are comparing by age, so pay attention to that. When you are sorting, you can either sort alphabetically or you can sort using numbers. So this person is younger. He is supposed to be here. So we move this person here, we move this person here. So we do this, move huyu huku, move this here, move this person here. Okay? Now, what will bubble sort do again? The next iteration, because bubble sort works after every move. After you've moved, it goes back and starts at the first of the at the beginning of the list. So again, it comes and starts here. It says, is Mary older than Trufena? Yes. Leave them alone. Don't swap them. It goes to the next person. Is Trufena older than Japheth? No, Trufena is not older than Japheth. Japheth needs to come here. Trufena needs to come here. So we now have a new list. Okay? So we'll copy this, move it here, and then we swap these two. This one comes here, this one comes there. Okay? Like so. Okay? Now, when the code runs again, where does it start? It starts at the beginning of the list. Okay? So now our code is here. It checks. Is Mary older than Japheth? No. So Mary should not be here. Mary should be here. So Mary will be moved here. Japheth will be moved to the beginning of the list. And then Mary moves here. Okay? Our code runs again. So when our code runs, because remember when sorting, the code does not just run once. It runs a couple of times trying to sort everything. Okay? So now we are here. We begin at the beginning of the list. We see, is Japheth older than Mary? Correct. Leave them alone. Is Mary older than Trufena? Correct. Leave them alone. Is Trufena older than Marlon? No. Move Trufena here, Marlon here. So we have a new list again. Okay? So here we will have Trufena moving to this side and Marlon moving to this side. And then Trufena is here. Okay? Now we proceed. We get a new list so that we work with a new list. So now, as you can see, the sorting is coming into place, but we are not done yet. There's somebody here who is younger than the person here, but our code starts from the first. So our code comes here. It checks, is Japheth older than Mary? Yes, leave them alone. Is Mary older than Marlon? No. So Marlon should be here, Mary should be here. So Mary will move here, Marlon will move here. Okay, move here. All right. And then now we have a new list. So this is our new list. So we've ordered these people. We've moved them. We have a new order. But it's not yet there. Okay. So again, we start at the beginning. Is Japheth older than Marlon? Yes. Leave them alone. Is Marlon older than Mary? Yes. Leave them alone. Is Mary older than Trufena? Yes. Leave them alone. Is Trufena older than Tate? No. Swap them. So Tate will come here and Trufena will come here. Okay, like so. And now we have a new list that we want to work with. So is our list now well organized? No, it's because this person is older than this person. Okay, so we start at the beginning of the list. Is Japheth older than Marlon? Yes, leave them alone. Marlon older than Mary? Yes, leave them alone. Mary older than Tate? No, swap. So we will keep repeating the same pattern until now Tate comes to here and these two move here and Tate comes here. And now our list is sorted. Okay, our list is sorted. So we have the oldest child here. They are given the food, the first. We keep going up to the last born. Is that a little bit better understood? Is that understood? All right. So our list is sorted, okay? But we want to do more things with our list. We cannot just sort and leave it like that. We want to do more things, okay? We might want to search and find out which of these children is aged 23, okay? Which of the children is aged 23? Now, if we are using what we call linear search, we start at the beginning here. Let me just swap this arrow. So we've sorted our list and we want to find out who is aged 30 or 23. Let's use 23. Who is aged 23? So the question here becomes, which child is 23 years old? Okay. Now, if we use linear search to search, this is linear search. Okay. We are searching from the beginning moving towards the end without doing anything else. So we begin at the first. Japheth is not 23 years old, move to the next person. Ted is not 23 years old, move to the next person. Marlon is not 23 years old, move to the next person. Mary is 23 years old, correct? We are looking for Mary. So we find Mary. Now, how many seconds has it taken us to find Mary? Let's say it has taken us 20 seconds. Okay? It has taken us 20 seconds to find Mary. But somebody else does not want to use bubble search. Sorry. They don't want to use what you call linear search. They want to use another method to search, which is way faster. So this person will say, okay, I'm looking for a person aged 23 years old. Okay, so what I will do, I will split these people into two groups. Okay, and I will split them at 30. I will say 30 years old go to this side and less than 30 years old go to this side. So now I have two lists. I have less than 30 years old and then I have 30 years old and above going to this side. Now I tell myself, if I have split the list into 30 plus and 30 minus, I don't have to bother with the people who are 30 years old and above, because I'm looking for a 23-year-old and they cannot be in the 30-year-old and above group. So I will focus on the group that is 30 years and below. Okay, so in that case, I will focus on this group right here. Okay, and I will check again. Between these two people, who is age 23 years old? It's Mary. And then I have my Mary. So in my case, if I use, this is what we call, I have forgotten, my goodness, what is it called? Binary search, yes. So my method here for searching is what we call binary search. Binary search. And if you remember from the word binary, male, female, two groups, okay? Just think of it like that. Binary 1, 0. Binary means 2. So we split our list into 2 until we find what you're looking for. So this is binary search, and this person, it might take them even 5 seconds. Okay? Because all they have to do is go through 2 steps. Number 1, split them into 2 groups. And number 2, go to the group that you want to focus on. And there you find the person you're looking for. So this is binary search. Is now everything well understood? Albert Kipkorir, I'm glad. All right. So that's exactly what we've been learning today. As a matter of fact, I think I should have just started with the Casquez family. It would have been way easier for you guys to get it. But it was also important for you guys to go through all these so that you understand the implication. You see, now in the real world, we can replace with Casquez siblings with an actual, like group of users, or we can actually replace it with what, students. Okay, so we can say instead of Casquez family we have students here, and instead of age we have their scores, and we want to find out which student scored the least. And in the list of students we have already sorted the students in alphabetical order, so that is the existing list. But we want to find out which student scored the lowest, so we have to arrange them as per what they scored, and that is what we've just done here. All right. Yeah, I think I'm even beginning to have a running nose because of all the explaining. But yeah, that marks the end of this session. If you found these very challenging, I will share the notes. Go through the notes. You can also take advantage of the office hours, where we meet and talk about some of these things in greater detail, and also explain the parts that were a little bit more confusing. I hope you all are on Discord, and I hope you all have donated for the course, because you see, water is not free, especially from this part of the country. So, and I need lots of water for coffee and for drinking. So do send your donations using the numbers provided, PayPal or M-Pesa, and I will really appreciate that. I'll see you guys in the next class. Bye.